In this video, I'm going to talk about the function sine. I'm going to talk about the history of sine, the right triangle definition of sine, the unit circle definition of sine, trigonometric identities about sine, the law of sines, the formula for the area of a triangle using sine, and how to find the stronghold in Minecraft using sine. This is my ratio project. Before we start, let's go over the history of sine quickly. The word sine came from the Latin word sinus, which means bay or inlet. A trigonometrical method similar to the sine function was found by Ptolemy of Roman Egypt, an astronomer, and Hipparchus of Nicaea, also an astronomer. However, sine as we use it today was developed in the medieval period. Sine is one of 6 trigonometric ratios. In a right triangle, the sine of an angle is defined as the opposite over the hypotenuse. However, using our right triangle definition of sine, we can only take the sine of angles greater than 0 and less than 90 degrees. To find the sine of other angles, we will need to redefine sine using the unit circle. Here is an image of the unit circle. To create an angle using the unit circle, we rotate the point 1, 0 counterclockwise around the origin by the angle we want to make. This resulting point is called the terminal point. Now, we draw the radius from the center to the terminal point, creating our angle, which we will call theta. To use this angle, we drop a perpendicular from the terminal point to the x-axis. Now, we have a right triangle with hypotenuse 1, and we can say the legs have length A and B. We see that if the legs have length A and B, then the coordinates of the terminal point will be A, B. Now, let's find A and B. Taking the sine of theta, we see that sine theta is equal to B over 1. So B is equal to sine theta. We also see that cosine theta is equal to A over 1. So A equals cosine theta. So, the terminal point has coordinates cosine theta, sine theta. Now we have defined sine and cosine for all angles, because cosine theta and sine theta are the x and y coordinates of the resulting terminal point. When we rotate the point 1, 0, theta degrees counterclockwise around the origin. Here are some examples of using the unit circle on Desmos. Now we are on Desmos. As you can see, A is the number of degrees we are rotating the point 1, 0 counterclockwise around the origin by to get our terminal point. Then we can find sine A by looking at the y-coordinate of the terminal point. For example, if A is 200 degrees, then the y-coordinate, which in this case is negative 0.342, should be the sine of 200 degrees. Let's check that with the calculator. And we see that we get the same number, negative 0.342. Using the unit circle, we can also find the sign of negative numbers. Now on Desmos we can only go to negative 10, so let's try that. The y-coordinate of the terminal point now is negative 0.1736. So the sine of negative 10 degrees should be negative 0.1736. If we check this with a calculator, we see that again we get the same number. Now that we have found out how to use the unit circle to define sine, let's use it to find some trigonometric identities. A trigonometric identity is an equality about trigonometric functions which is true for all values of the variables for which the equation is defined. In this section of the video, we will learn about some useful trigonometric identities involving the function sine. Unfortunately, there won't be enough time to go over these in detail, But here are 11 trigonometric identities that are about sine and are very useful. The first 5 can be proven quite easily using the unit circle, but the others have a more rigorous proof. Now, we are going to move on to an extremely important trigonometric identity known as the law of sines. The law of sines is a relationship between the sides of a non-right triangle that says the ratios of the angles in a triangle and the sides opposite to them are equal. In other words, if we have a triangle with angles A, B, and C, and side lengths A, B, and C, the law of sines states that A over sine A is equal to B over sine B is equal to C over sine C. This can be proved using this diagram. Using the diagram, we can find sine A and sine C, then multiply them by C and A respectively. Then, we can draw the perpendicular from point A or C instead of B, and then do this again for the last vertex. By the end, we get sine A over A is equal to sine C over C, sine A over A is equal to sine B over B, and sine B over B is equal to sine C over C. So sine A over A equals sine B over B equals sine C over C. Using this diagram, we can also prove another very important formula. We can use sine to find the area of a triangle. Here is the formula. To prove this, use this diagram to express the height as the sine of an angle. Then substitute this value into the most commonly used formula for the area of a triangle, base times height over 2. Why is this formula useful? It allows us to find the area of a triangle without the base and the height of the triangle. So, we have another way to find the area of a triangle if we don't have that kind of information. We know how sine can be used in math, so now let's talk about how it can be used in Minecraft. In Minecraft, the sine function can be used to locate the stronghold using a technique called triangulation. Triangulation is the method of finding the stronghold by finding the intersection point of the two rays created by two different eyes of Ender, a technique used by many speedrunners. Let's go see how this works. So we start by throwing an eye of Ender, and then we look directly at it, so that's where it went. So now we press F3, and that number is the angle measure that we need. So right now it reads 61.9, so you write that down. And in case you're wondering, this angle right here, that angle, is the angle between the way we're facing and this side. As you can see, if we face this way, we get 0, close to 0, because I'm not doing it exactly. But it's the angle between this side and this side. And then we turn this way. So it's kind of like a backwards unit circle. So now we have that number down. Now let's move 100 blocks, 100 blocks horizontally. And now, we're 100 blocks away from where we were before. As you can see, our previous z-coordinate was negative 1338, and now it's negative 1438. So let's throw another eye. It's going this way. And now, the angle we get is 39.8. So let's write that down. And now, we are ready to create our diagram. Okay, so here's the diagram we can make based on the information we have gotten. Using the law of sines, we can calculate the other two side lengths. If you want to be more exact and find the x and z distance, we can create a right triangle like this and find that information as well. Doing so, we can locate the stronghold with only 2 eye of Ender tosses.